students, today I'm going to take a new topic, right? So the topic is acoustics, right? So unit 5 is the fifth lesson, acoustics. Okay students, right? Shall we go to the topic? Okay students, okay, see this, acoustics, right? A small introduction. See, acoustics is a branch of physics that study the sound. Okay, so acoustics, it is a branch of physics so that study the sound. Okay, students, right? And see the second point, acoustics concerned with the production, control, transmission and effect of sound. And the study of acoustics has been fundamental to many developments in the arts, science, technology, music and biology and etc. Okay, so this is the introduction of acoustics. Okay students, so what is acoustics? Acoustics is nothing but one of the branch of physics which deals with sound. Okay, right. Now come to the sound. Okay, so what is sound? So acoustics which deals with sound, right? So come to this point, what is sound? Sound can be described as a disturbance or turbulence which passes through a physical medium in the form of longitudinal waves from a source to a receiver, causing a sensation of hearing. So it is a disturbances, right? So this medium will be solid and fluid or gas. Okay, and the speed of sound through these different media differs due to their molecular composition. Now come to the simple definition of sound. Sound is any vibration traveling through the air or other medium which can be heard when it reaches a person's ear. Okay students, right. Amplitude and volume is, why sir here amplitude and volume? I'll tell you. The amplitude of a determines a sound volume. So volumes tells how loud or soft a sound is, determined by how much energy a wave carries. And amplitude describes how much energy a wave is carrying. Yes, how much energy wave is carrying. So amplitude describes the energy and the volume, yes, gives that loudness or softness of a sound. Okay, and now in amplitude, more energy is equal to or greater amplitude or is equal to louder sound. So more energy, that is equal to high amplitude, and high amplitude, that is equal to loud sound. Okay, and see this high amplitude. See, amplitude is very high, definitely the sound is more, that is loud. When the amplitude is low, it is quiet. In a higher amplitude, loud, and the other is quiet, right? Okay students, okay, right. Now what is sound? Again, yes, for understanding purpose, simple definition. See this, sound is a vibration in any elastic medium with a definite frequency and intensity. Okay, sorry. And yes, the sound is a vibration in an elastic medium with defined frequency and intensity, right? Okay, now again, it is a longitudinal wave. It requires a medium to travel, and it cannot travel in a vacuum. The sound cannot travel in vacuum. It requires a medium, either solid or liquid or gas. Okay, so it is a which wave? Longitudinal wave. Okay, students, right. Now come to the sound waves, and this is that tuning fork, right? And this is that vibration sound and particles, and these are the compressions and the rarefactions, because the longitudinal waves produce compressions and rarefactions. Yes, see this side is that rarefactions and this is the compressions, right? This is that compressions. Okay, okay students, right? So this is what? Compressions. Okay students, right. What are waves? Now, what are waves? A wave is a phenomenon in which energy is transferred through vibrations. A wave is a phenomenon in which energy is transferred through vibration. Okay, so this is the, see this is the wave format in water, wave forms in water. Okay, okay students, right. And now classification of sound based on the frequency. Yes, sound is nothing but what? Vibrating particle. No, now classification. The sound classified based on the frequency. Okay, and the frequency measured in hertz already we know. Yes, hertz is nothing but unit of sound, right? Now based on the frequency we classified into three types. The first one is infrasound, that is infrasonic. Yes, the frequency of sound is below 20 hertz, below 20 hertz, that is infrasonic sound. Okay, now come to the next one, audible sound. So the human ear, yes, hear the sound between 20 hertz to 20,000 hertz, that is 20 kilohertz. This 1 kilo is k is nothing but kilo, 1000, therefore 20,000 hertz, that is the audible range. So within this frequency all the sounds are audible. Okay, and now come to the third one. Yes, if the frequency is greater than 20 kilohertz, that is 20,000 hertz, that sounds are ultrasonic waves or ultrasound. Okay students, these are the classification of sound. Okay, what are the classification? Infrasonic or infrasound, audible sound, and ultrasound. If you go to hospitals, ultra scan is there, no? In that scan they are using ultra is sound frequency. Okay, because that frequency of the is waves, it is greater than that 20,000 hertz. Okay students, right. And next come to that categories of sound waves based on frequency in our book. Okay, the same is given. First one is audible waves. The first one is audible waves, and these are sound waves with a frequency ranging between 20 hertz to 20,000 hertz, and these are generated by vibrating bodies such as vocal cords and stretched string. So this is audible waves. Yes, that is audible sound. And now come to that infrasonic waves. Second one is infrasonic waves, right? And these are sound waves with a frequency below 20 hertz, below 20 hertz, that cannot be heard by the human ear. Example, waves produced during the earthquake and ocean waves and sound produced by yes, wireless and etc. Okay, and the third one is ultrasonic waves. And these sounds are by sound waves with frequencies greater than 20,000 kilohertz. The human ear cannot detect these waves, but certain creatures like mosquito, dogs, bat, and dolphins can detect these waves. Example, waves produced by bats. Example, waves produced by bats. Okay, students, these are the categories. Now come to the gain. What is sound? So sound is a really tiny fluctuation for air pressure. Okay, fluctuation of air pressure. The unit is Newton per meter square or SPSI. Okay, and it carried through air at 343 meter per second. 343 meter per second as compressions and rarefaction in the pressure. Okay, this is the another definition of sound. Okay, students, right. Now come to the properties of sound, that is musical sound. It has properties, no? That's why the properties of sound. Yes, see the properties. Regular in shape. So musical sound is regular in shape and have defined yes periodicity, and they do not undergo a sudden change in amplitude. They don't undergo that sudden changes. Okay, okay, students. Now, yes, continuation. The sound wave the sound wave is alternating high pressure and low pressure. Okay, and the sound is a longitudinal wave. Okay, and meaning that motion of particles. Right? Yes, the motion of particles in along the direction of propagation. Along the direction of propagation. It is a diversion, right? And see this is that wave format, and this is the amplitude. Okay, now come to this one. Continuation. Why is sound longitudinal? Okay, students, this is continuation. Now see this first one. Waves in air can't really be transverse because the atoms or molecules are not bound to each other, right? Yes, and it can pull a neighboring molecule sideways, and only if a rubber band connected the molecules would this work. And okay, and fancy way of saying this, gases can't support shear loads. That means air molecules can really only bump into one another. That means here the waves is can't really be transverse. That means here the sound waves are only in longitudinal. See this. So this is the waveform, and this one is undisturbed molecules, this line, and yes, vibration molecules like this, and molecular displacement like this, displacement, right? And lambda is their wavelength of this wave. Okay, this R and C, R means rarefactions and C means compressions. So in longitudinal wave produce compression and rarefactions. Okay, students, right? Okay, next come to the properties of waves. Yes, there are two property. One is wavelength and frequency. And see this is one wave format, right? And the distance between these two, right? The distance in longitudinal wave, the distance between any crust to crust or in longitudinal waves compression rarefactions, no, that's why uh, compressions to compressions, that distance is a wavelength. That's why see here, wavelength is measured from crest to crest, or trough to trough, or upswing to downswing. That is wavelength lambda. Okay, and this for traveling waves, for like sound waves or light waves or water waves, there is a speed, that one denoted by c. Okay, next frequency. The frequency refer how many cycles pass per second. Yes, the frequency measured in hertz denoted by Hz, number of cycles per second, and the frequency associated with time period, that is t is equal to time period, time taken by the wave to complete one cycle, that is t is equal to 1 by f. So these are all is closely related. What are three things? Speed, wavelength, and frequency. Therefore the relation between these three is equal to lambda f is equal to c. Lambda f is equal to c. These are the properties of waves. Okay students, right? Okay, and now come to the frequency of sound. Yes, and this I see this amplitude, and this is also amplitude, and this is also amplitude. See the, but see the variation, see the peaks are very high and the peaks differ than this. See this differ than this. See that frequency and the amplitude variation, right? See this first one, we hear frequency of sound as having different pitch. A low frequency sound has low pitch, like the rumble of a big truck, right? And a high frequency of sound has a high pitch, like a whistle or siren. So high pitch, right? In speech, women have higher s fundamental frequency than men. Okay, for speech women have higher fundamental frequency than men. Okay students, right? Okay, now complex of sound. So the complex of sound is made from many frequencies. For example, see this different frequencies, either 264 hertz, 330 hertz, and 396 hertz. Yes, see this, the speaker produce sound, and the sound is going to superposition principle, and here the I, and see the differences. Okay, the brain breaks down complex sound into perception of each separate frequency. Then when we hear complex sound, that is a high frequency sound, the nerves in the ear respond separately to each different frequency. The brain interrupt the signal from the ear and create a sonic image from the frequencies. The meaning in different sounds in derived from patterns in how the different frequencies get louder and shorter. Okay, so this is a complex of sound, right? Okay, now come to the sensitivity of the ear. Yes, see this decibel level. Decibel is that sound value. Yes, sound capacity, that is the decibel. Okay, that is a noise or pollution measured in decibel values. And see this is the frequency, right? Now this is the loudness curve, the curve between the decibel level and the frequencies, right? See this first one, how we hear the loudness of sound is affected by the frequency of the sound as well as by the amplitude. The human ear is most sensitive to sound between 300 to 3000 hertz. See 300 to 3000 hertz. The ear is less sensitivity to sound outside this range. Most of the frequencies that make up speech are between 300 and 3000 hertz, right? So this is the most sensitivity. Okay, okay students, right? Now come to the classification of audible sound. Yes, right. See, the sound audible sound classified into two types. One is musical and noise. Right. Come to the musical. Musical is nothing but the sound which produces pleasing effect on the ear is called musical sound. The sound which produce pleasing effect on the ear is called musical sound. Sounds of sitar and violin and flute. Examples, right? And now come to this say noise. The sound that produces is jarring effect on the ear and unpleasant of ear is called noise. Examples: sound of road, traffic, crackers, and airplane. So these are the examples of producing noise. Okay, right? Shall we go to next slide? Okay. Now recording sound. Yes. See this sound wave, and this is a microphone and the electric signal. So sound signal is converted into electric signal with the help of which one? Microphone. With the help of microphone. Okay. Yes, that's why see this. A common way to record sound start with a microphone. A microphone transforms a sound wave into an electric signal with the same pattern of oscillation. So here the sound wave is converted into electric signal, yes, with the help of microphone. Okay, students, right. Now continuation. The electric signal is amplified until it is powerful enough to move the coil in speaker and reproduce the sound. So here the sound wave is converted into electric signal with the help of microphone, right? The same way the output is given by the speaker. In the speaker, the output is sound wave, because the electric signal is converted into sound wave with the help of amplifier and reproduced by the speaker. Okay, so speaker is the output, right? Okay, students, right. Intensity and pitch. In sound waves, intensity is very important and pitch also very important, right? See the first point, pitch. The pitch of a sound depends on the frequency of the tone that ears receives, right? And high notes are produced by an object that is vibrating a greater number of times per second than for a low note, right? And the intensity, right? See the second point, the intensity of a sound is the amount of energy crossing a unit area in a unit time, or the power flowing through the unit area. The SI unit is watts per square meter. So this is very important, watts per square meter. Okay, students, right. And third point, the loudness of the sound depends upon the subjective effect of intensity of sound waves on the human ear. So pitch, intensity, and loudness, right? So these are the important terms in sound. Factors affecting the speed of sound. So some factors are affecting, no, the factors are pressure, atmospheric pressure, and relative humidity and atmospheric temperature. These are the three factors, right? In high atmospheric pressure and relative humidity and atmospheric temperature lead to is faster moving sound. What are the factors? Atmospheric pressure, relative humidity, and atmospheric temperature. Okay, students. And now first one is, see the same one, factors affecting the velocity of sound. The same one is in our book is given. In the case of solids, the elastic properties and density of solid affect the velocity of sound waves, right? An elastic property of solid is characterized by their elastic moduli. The speed of sound is directly proportional to the square root of the elastic modulus and inversely proportional to the square root of the density. So therefore, The factors are, yes, first density, yes, effect of density. Now see this. The velocity of sound in a gas is inversely proportional to the square root of the density of the gas. Therefore, if the velocity decreases as the density gases of gas increases. So if the velocity decreases, right, the velocity decreases and the density of gas increases. That's why inversely proportional. See this, it's very simple. Whenever write the definition, compulsory you should write the formula. What is the formula? V is uh, inversely proportional to square root of 1 by d. D is the density of in gas. Okay, right. And next, effect of temperature, right? See this, the velocity of sound in a gas is directly proportional to the square root of its temperature, and the velocity of sound in a gas increases with increase in temperature. Therefore, V is directly proportional to T. So please note it down. V is directly proportional to square root of T. And yes, the velocity at temperature T is given by following equation. This is very important equation. So Vt is at particular temperature, velocity of the sound in at particular temperature, and V is equal to V naught plus 0.1 T meter per second. See this, V naught is the velocity of sound in the gas at which degree? 0 degree Celsius, right? So for air, the velocity is 331 meter per second. Yes, so then the velocity of sound changed by 0.1 meter per second, because when the temperature changes by 1 degree Celsius, changes into 1 degree, yes, 1 degree Celsius. Okay, okay students. Now see the next effect, humidity. The humidity increases, the speed of sound increases. That is why you can hear sound from long distance clearly during the raining season. That means in raining seasons the sound will be a differ, no? Yes, that's why, because the humidity increases, the speed of sound also increases. Okay, okay students, right. Then velocity of sound waves. When you talk about the velocity associated with any wave, there are two velocities, namely particle velocity and wave velocity. Because sound waves, particle and wave, right? So there are two velocities. One is particle velocity, another one is wave velocity, right? So the SI unit of velocity is the SI unit of velocity is meter per second, ms power minus 1. Okay students, there are two velocity, one is particle velocity and wave velocity, right? So now see the first one, particle velocity. The velocity with which the particles of the medium vibrate in order to transfer the energy in the form of wave is called particle velocity. The wave velocity is the wave, yes, wave velocity. Now again I'm reading the particle velocity. The velocity with which the particle of the medium vibrate in order to transfer the energy in the form of a wave is called particle velocity, right? So here particle only taking, but go to the wave velocity. Wave, here we are taking wave. See that the velocity with which the wave travels through a medium is called wave velocity. In other words, the distance traveled by a sound wave in unit time is called the velocity of sound wave. So the velocity is denoted V. Thus derived velocity is equal to distance by time taken. Distance by time taken, or otherwise d by t. D is taken as distance and t is time taken. This is the velocity of sound waves. Okay, students, right. Now come to that difference between the sound waves and the light waves. Okay, now see the first point. In sound waves, medium is required for propagation. Yes, but if we go to this light, medium is not required for the propagation. So here is required and this is not required. And sound waves are longitudinal waves, just opposite light waves. Light waves are transverse waves. And here sound waves, the wavelength range is from 1.65 centimeter to 1.65 meter, but the wavelength ranges from the light 4 into 10 power minus 7 meter to 7 into 10 power minus 7 meter. And now come to the sound waves, travels in air with a speed of about 340 meter per second at a normal, yes, temperature pressure. Yes, 340 meter per second and ANTP. Okay, and now here light waves travel in air with a speed of 3 into 10 power 8 meter per second. Okay, students, right? Students, today class is over. Okay, students, please underline some important points in your book. Okay, okay, students, we'll see you on next video. Okay, students, thank you, students.